In this tutorial on preparing solutions, we're going to learn a little bit more about differentiating between the terms dilute and concentrated. And we've talked about these terms in earlier work, but we'll continue to explore here. And then we're going to take a quantitative approach and find out what happens to the concentration of a solution when it is diluted. And we'll use this formula C1V1 equals C2V2 to help us do that. And then I'm going to talk a little bit about how to prepare a solution of a given concentration, and we're going to do more with this during class time. So we're going to start here by looking at this situation where you've got 0.1 liters of 0.05 mole per liter iodine, and some water is being added to it. And enough water is added to give you a final volume of 0.5 liters or 500 milliliters. And we are asked to find the molar concentration of that final diluted solution. So first of all, what has happened, or how do we know that the solution has been diluted? Well, if we take a look at the the molecular view of the original solution, the purple molecules represent the solute molecules, and you see, as compared to the diluted solution, there is a lot more solute molecules in this first situation per unit volume than there is in this situation. And that's really the nature of a dilution, that more solvent has been added. In this case, the solvent is water, and as a result, you have a lower concentration of solute molecules. And the concentration values you see below support that idea. And sometimes this original solution is also called the stock solution. So the stock solution is what you use to make your diluted solutions. And so then we come to this question about which solution has more moles of the iodine solute, the original concentrated solution or the diluted solution. And so I want you to think about that for a second. Which one do you think would have more moles of the iodine solute? Well, it turns out that they actually have the same number of moles, because we didn't change the amount of solute in this situation or in this situation. All that was changed was the concentration. And so, since the number of moles in the initial solution is equal to the number of moles in the final solution, and we can represent that using this, then we can say that from the formula C equals N over V, we can rearrange that to give N equals C over V. And so the number of moles is equal to the concentration in moles per liter times the volume in liters. And we end up with a formula like this by substituting this in on my left-hand side and also substituting this in on my right-hand side. We get the formula CIVI, and actually just looking at this should be a lowercase c in both cases, or in all cases here. But CIVI, so the concentration of the initial solution times the volume of the initial solution, equals the concentration of the final solution times the volume of the final solution. And again, this statement or this equation is true because the number of moles doesn't change in this situation. When you dilute a stock solution, you're not changing the number of moles, you're just changing the concentration and the volume. Sometimes, and actually this is the way that I prefer, you'll see C1V1 equals C2V2. It means the exact same thing, it's just that it's talking or referring to C1V1 would be one solution, and C2V2 is referring to the characteristics of the other solution. And so now we can use this formula to calculate the concentrations when a solution has been diluted. And I really want to stress that this formula, the C1V1 equals C2V2, is applicable. I only want you to use it in situations where you have a dilution, where you have diluted a solution. There are other instances where it is possible to use it. I just think if we have the mindset that this formula is relevant to dilutions, you don't get yourself in trouble when you try to apply it in some situations where it can't be applied or it can't be used. So solving or using the data from the original example, so the concentration, the concentration of the original solution and its volume, so the 0.05 moles per liter, and the 100 milliliters here, 0.10 liters. And we are told that the solution was diluted to 0.50 liters. We're trying to find what that final concentration is, or we're trying to find the concentration of the diluted solution. And so to find that, we simply rearrange this formula, solve for C2, sub in what we know, and notice that our units cancel out, our liters cancel out. We are left with moles per liter, which is what we want, and we end up with an answer of 0.010 moles per liter. And this answer makes sense because we know the solution was diluted, and so C2 should be less than C1. If C2 represents the concentration of the diluted solution, then the concentration should be less since it was diluted. And so now just really quickly looking at figure 2 here, which talks about preparing a solution using a solid solute. This figure summarizes some of the key steps in doing this. And so once you have weighed out the appropriate amount of your solute, you're going to add it to the volumetric flask, but before you add it, have a portion of your solvent already in the flask. So maybe fill it 1/3 full, and you're going to then add your solute, and then you're going to swirl it, and you're going to swirl it until all of the solute is dissolved. And this is key because when dissolving takes place, sometimes there's a change in volume due to mixing, and so you don't want to add all of the water before you or all of the solvent, I should say, which is usually water, before you have dissolved your solute. Otherwise, you might not have the appropriate final volume. And the appropriate final volume, of course, is when the meniscus is just touching this line. And so you don't see it very well here, but the line right here, this special piece of glassware is called a volumetric flask, and it very precisely measures 500 milliliters. And when the solution that is in the flask, when its meniscus is just touching that line, you have exactly 500 milliliters of solution. And so that's why it's key to get all of your solute dissolved by swirling it like we did here, and then filling it up to volume using your solvent. And so in this tutorial, we have focused on talking about what a dilute solution looks like versus a concentrated solution. And then we've also taken a look at using the formula C1V1 equals C2V2. And I said that one of the things I really want you to keep in mind is that we only use this formula when we are doing dilution calculations. And we also looked at how to use the variables, so how to assign information from a problem or a situation to each of the C1V1 and C2V2 variables and solve for the one variable that we don't know.